Everyone, welcome back to Mathematics Made Easy. So for today, we are going to be doing trigonometric ratios. Now, there are 6 trigonometric ratios that we have. We have the sine, we have the cosine, we have the tangent, we have the sine, cosine, tangent, we have the cosecant, we have the secant, and we have cotangent. Now, each of these ratios has their own definitions. For instance, sine here is equivalent to opposite over adjacent. Sorry, opposite over hypotenuse, not adjacent. And then cosine here is adjacent over hypotenuse. Then tangent here is equivalent to opposite over adjacent. Then cosecant here is simply the inverse of sine, so it is 1 over sine. And then secant here is simply the inverse of cosine, so it is 1 over cos. And then cotangent here is the inverse of tangent, so it is 1 over tan. I know this might seem like a lot to remember, but there is also an abbreviation for it. For instance, we have our SOHCAHTOA. And this abbreviation here is for the first 3. So sine here is opposite over hypotenuse. Cos, adjacent over hypotenuse. Tan, opposite over adjacent. And now for these other 3, to remember it easily, this here now looks like the combination of cos and sine and sec. So the second one here, the sec here, just know that cosec is the inverse of it. And then for this one, we have c here, cos. So this here is the inverse of cos. And then for this one, we have tangent here. So this here is the inverse of tan. I hope this helps you remember it. Now, these trigonometric ratios are used to find the sides. They are used to find sides and angles in a right angle triangle. So what this means is that before you can use any of these trigonometric ratios, you have to make sure that you are dealing with a right angle triangle. You have to make sure that the triangle you are dealing with is a right angle triangle. And remember, a right angle triangle is a triangle that has a right angle that is 90 degrees as one of the angles. So now this here is a right angle triangle. And I told you that when dealing with a right angle triangle, that the longest part, which is the part opposite to the right angle, is usually the hypotenuse. Then any of these parts can be opposite or adjacent depending on the angle that you are making use of. So let's assume that this here is adjacent. Maybe the angle we are dealing with is here. Let me just call it theta. So this here is adjacent and this here is my opposite. So the angle or the side opposite the other angle that you're dealing with is the opposite. And then where the angle is lying is the adjacent. So now, these trigonometric ratios are used in a right angle triangle when you are given either of these angles. I'm not talking of the right angle, I'm talking of the other 2 angles. So when you are given any of these 2 angles and any of this side and asked to find the other side, maybe you are given this angle here and you are given adjacent, and now you are asked to find opposite, you can use these trigonometric ratios. Or maybe you are given these 2 angles and any of the sides and asked to find the other one. Or you are given 2 sides and you are asked to find the angle. Or maybe you are given the 3 sides and you are asked to find a particular angle. Just know that you can make use of these trigonometric ratios. Now I'm going to move over to telling you how you can know the most appropriate trigonometric ratio to use to find a particular side that you are asked to find. Now let's assume that in this particular right angle triangle that I sketched here, that you are already given this angle as theta, and now you are given the opposite. Let me call it, you are given A, and now they asked you to find this place and you are not given here. So all you have to do is you come here to the ratios, you can just write it out somewhere, maybe at the edge of your book, and then you can now check. Since you are given opposite and you are asked to find adjacent, now which of these trigonometric ratios has opposite and adjacent in it? Now when solving like this, what you have to be making use of is the first three, because they are the basic ones. So you have to make use of sine, cosine, or tangent. You can neglect these ones because whatever you have here, these ones are simply the inverse of them. So now when you are given opposite and you are asked to find adjacent, all you have to do is look for the one here that has opposite over adjacent as the ratio, or maybe adjacent over opposite as the ratio. Now if you look here, you will see that the one that has opposite and adjacent in the ratio is tangent here and cotangent. But since I don't want to deal with inverse for today, I'm going to be making use of this one. So let's assume, now let me solve an example. Let's assume that you were given a triangle, and now you are given that this here is 3 kilometers, and you are asked to find this place. Remember, this is a right angle, so this is 90 degrees, and maybe you are given this place as theta. So now the one that has opposite and adjacent in it is tan. So all you have to do is tan theta is equivalent to, opposite comes first, so 3 here will come first, is equivalent to 3 over, let me call this x, and that's it. So when you solve, assuming you are given a particular angle here, when you find the tangent of that angle that you are given, you can cross multiply and then divide with the coefficient of the unknown. So I hope this was very helpful, and if you have any questions, please feel free to ask. I'm going to be making a subsequent video to show solvings or maybe examples for these trigonometric ratios, but for today I'm going to be stopping here to make. So if you have any question, or there is anything you don't understand, or any topic you would like me to make a video on to explain in details, or any question you would like me to solve, please make sure to comment it on the comment section, and I will be very much excited to get back to you. Thank you.